Implicit differentiation. So, very nice topic, nice idea. Students usually do not like it. But we'll see. We'll see if you like it. Some people like it because it's very logical, but some people get lost in the number of steps. They don't really like it because it's too many steps to remember. But the idea is, what if we cannot solve for the function f if we want to find derivative first? Then what do you do? What do you do if you cannot do that? Does it make sense to you? I will write down the example right now, but this is the most common thing that happens in biology. We are not given the function in the form y equals blah, blah, blah. So optimistically, you are given the shape. Why zebrafish have stripes? There's a whole research done about that. Actually, why zebrafish has stripes, why zebras have stripes. There's a whole mathematical biology image recognition happening there. Why they develop stripes? Nobody has a function that looks like this. Oh, this is the function that explains how the colors are changing on a zebrafish. That'd be very optimistic. If you have this, and you ask it to find y prime, it's 5x to the 4 plus 5. This is what you call explicit differentiation. Basically, you're lucky. You're lucky to have explicit function y, and then you can do explicit differentiation. And that's what we did before. Because we had to teach you how to differentiate, we showed you all the simple examples. But in applications, in biology, in medicine, it's very naive to believe that all of functions are given so beautifully. Usually your function y is hidden somewhere like so, explicitly, x times y minus 7y cubed. Maybe even have some trigonometric function with y. Now what you're gonna do? How would you find y prime, which still represents something important, if your y originally is not given explicitly, it's given implicitly? And that's why implicit differentiation was created. So it's very possible you will be dealing with this in your career, or at least you'll recognize it in the book or scientific article. Given something explicitly versus implicitly, research usually does not have explicit definitions. It's rare. So students who do my honor projects, we are actually a rare example in epidemiology that we have y equals numbers of patients, y equals numbers of sick people, recovered people, immune people. That's rare. Yes?
Couldn't I just take the sign minus 1 of each side and then...
So you want to solve? Sometimes you can try to solve. And if you did, good job for doing that. But if it's hard to solve or sometimes impossible, you differentiate implicitly. So don't find f of x if it's too hard. Just differentiate implicitly. And we're going to teach you how to do it right now. It's part of the research. So let's put versus. Explicit versus implicit. And I give very good steps in my classes how to do implicit differentiations. So students usually do really well on the test on this particular problem in my classes. Because I like giving steps, and students apparently like having steps. So some teachers criticized me for giving steps for things because they say that I'm teaching you memorizing things. And I am arguing this because as a mathematician, I like to structure the information. So I think structuring the information is not memorization. It's making things in order. So try not to memorize the steps, but if you do, you still do well on a test. So kind of we're all happy here. Step one, find derivative of the left-hand side and right-hand side. You see this mess? Just differentiate everything. So like the bomb just thrown at the whole village. Just differentiate everything. Find the derivative. Find the derivative of. And I really like English abbreviations of left-hand side, and right-hand side. LHS and RHS. So all sides, you just differentiate everything you see. The trick is to recognize that y and x are not equal. Every time you see y, every time you see y, you should remember that y is called dependent variable. Y depends on x, or t time, or g gravitational forces, whatever. Y is your output, which is also called dependent variable. Thus, by chain rule, the derivative of y is y prime, which is not 1. X prime gives you 1, but y prime will be dy over dx, or just y prime. So that's going to be important. You will understand it right now when I give you example, and you will see it makes sense. While every time you see x, the input, every time you see x, which is just input, it's independent variable, input, can be anything in a domain. The derivative of, well, the derivative is x prime, which is 1. And that's going to be a main difference. Both are variables, so you will have to do product rule if they are multiplied. But the way you differentiate each has different meaning. Y depends on x. Let me draw a picture for you. Y is outside, x is inside. X is independent, y is dependent. Because it's chained or nested inside of y, y prime is not 1. Y prime is derivative of y with respect to x, while x prime is just 1. So that's going to be interesting. That comes from chain rule. If you want to know the explanation, BC, because chain rule. Because of chain rule, so y that depends on x being differentiated gives you y prime, derivative of the function outside is y prime, times the derivative of x, which is 1. That's kind of how you can understand this idea. Make sense? Derivative of the function inside is y times derivative of function inside, which is x, which is 1. Yes?
Would you go
Yeah, let me know if it's too fast. Let me know. How's it going? So that was only step 1. Step 1 is just to find derivative, and that is the hardest step from all of them. After this, everything becomes algebra. It's not calculus anymore. And in calculus 3, step 1 becomes extremely challenging because it's differentiating in 3D. So it's also hard. But then everything else is very straightforward. You need to move. You want to solve for y prime. This is how I recommend doing it. Move parts that have y prime, so with y prime, or dy over dx, whatever your notation is, to one side. I usually write left-hand side to one side. But then I noticed that some students like to have y equals on the right-hand side. And left-hand side is the result. Very interesting. I never seen it before until recently. Some students have a flipped kind of brain that likes it this way, which is fine. It's not against the rule. But traditionally and internationally, we move unknown things to the left-hand side, right? Other stuff move to the other side. So in this case, to right-hand side. But makes sense. Important stuff with y prime goes to one side, other things to the other side. Our goal is to isolate dy over dx. This nice word was a suggestion from one of my students. I would say, I want dy over dx to be standing alone by itself. And then someone from the audience says, yeah, to isolate. And since then, I'm using this nice word. It's a very nice explanation. To isolate whatever we're looking for, which is dy over dx. Very nice. Step 3, factor out your y prime or dy over dx, whichever you write it down. So you will have, I'll put it in black, the shape that looks like so. Dy over dx, brackets or parentheses, you factor it out, equals something on the right-hand side. So because left-hand side had only stuff with y prime, you could factor it out. Finally, the last step, you divide by these brackets, and you are done. Last step, you divide by those brackets. And the answer will be exactly what you're looking for. The answer will be dy over dx equals blah, blah, blah. And that's going to be the answer. Right-hand side, which you moved from the very beginning, over the brackets, which show up from factoring. People right now like thinking, this is so boring. I will give you an example. You will see it's doable and might be your favorite example on the exam. So you will see. Let's do the example. Find derivative of y if y is hidden in the equation. You see, it's not given explicitly. It's given implicitly. Where is it? It's hidden over here. Yeah, I can see it just a second. I can see it over here and over here. Yes. Sure, no problem, yeah.
Until step 2.
Oh.
I like zoom out.
Like so? Are you making pictures instead of writing?
No, I want to write. It's just you're going a little bit too fast.
Yeah, no problem. Let me know. Let me wait. So the example I just showed you. And let's see. 3x squared plus 2x plus xy equals 4 minus 40y. How would you find y prime if y is hidden over there? Sometimes you can solve for it. In this case, we could actually solve for it. But we're going to show you implicit differentiation instead. Because most of the time, you cannot solve. So let's do it. Let's do implicit differentiation. Let's just throw the differentiation bomb into everything and see what's going to happen. Yes?
Is that like 4 minus 40y?
4 minus 40y. Yes. 4 minus 40y.
We just can't see the whole thing.
Oh, really? Oh. Okay.
And now we can't see anything else.
No, that's the most important information. 3x squared plus 2x plus xy equals 4 minus 40y. And then at the end, they ask us to plug something, which we're going to do at the end. Plug 4 and minus 13. I will explain what it means later. Let's do implicit differentiation. Step 1. Just differentiate everything. Easy to say, but keep in mind what x and y have in common but different. So, what is 3x squared when I take the derivative? 6x. Nothing complicated. What is 2x? 2. Now, x times y is actually a product rule. This is my u and this is my v. Product rule. Because both are variables. And they are different also. Y is a cool guy who will have y prime, while x is the simple guy who just has whatever we do right now. 6x squared, 6x and 2. It's like a simple differentiation. Y is a cool one, so you have to keep this in mind. It will be more complicated. Let's start doing product rule. I'm changing the color for you. Product rule. Derivative. Do you remember product rule? Yeah. Thank you. Oh my gosh, I'm so happy. Derivative of u. Derivative of x is 1. Agree? Derivative of u. That's x. Copy v, which is y. I'm copying. Plus copy u. So I'm copying x. Plus times derivative of y, which is not 1. It's y prime. I'm supposed to keep writing dy over dx, but y prime is faster to write. And until you go to multivariable calculus, it's not very important. In multivariable calculus, it's important to write down dy over dx. In this one, not really, and it's faster this way. So y prime is my favorite notation. This was product rule.
Is that parentheses important?
No, that's just for visual effect. No parentheses needed. That's just for visual. When you read these notes, it will like, oh, we did product rule. Right hand side, what is here? What does it give you? What's the derivative of right hand side? Oh.
-40y prime.
Negative 40y prime. All agree? So 0 minus 40, and then y does not give you 1. It gives you y prime. And that's the difference between y and x. Just remember, that was not too bad. So step 1 was successful. We finished differentiating. Ask me right now if you don't like it, yeah?
Should we simplify?
No, don't simplify unless you have to. You will have example when you have to distribute first. But in this example, no simplification needed yet. Step 2 says, identify things that involve y prime and move them to the left-hand side. So let me identify. This thing has y prime. and this thing has y prime. So I will move that to the left-hand side. This guy needs to be moved. And only keep those parts with y prime, because these are the most important ones, like so. See? Things that involve y prime should be moved to the left-hand side. If there is a number in front, you will have to distribute. Or if there is x in front, you will have to distribute. But in this case, we did not have to. So sometimes extra step is needed, but sometimes not. Everything else is a garbage. Move it to the right-hand side. 6x becomes minus 6x. 2 is minus 2. Y is minus y. So you see, we're relocating things. The goal is to isolate parts which are important. The goal is to find y prime, so let's isolate it. Move it to the left-hand side, factor it out. Step 3, factor out y prime. Factoring means dividing by. So I see this y prime and I see this y prime. I will divide by this y prime, open brackets or parentheses, whatever you like. Divide by it, so it gives you x plus 40. I have a YouTube video about factoring if you really want to review algebra. Because I did teach algebra class before, so I have it. And then the right-hand side is the same. The last step,
2 minus y, I thought.
2 minus y, thank you. Minus y. The last step, usually people skip to step number 4 right away when they see the pattern. The last step is always the same. Right-hand side minus those brackets. So if you can factor in your mind, you can write down immediately the answer. The answer is a fraction. Right-hand side over the brackets are x plus 40. And this is the answer. So many steps, but they're very straightforward. If you kind of do it several times, technically speaking, I can give you a test and you will be able to do it on Friday right away for this problem. Because it's kind of the same all the time. So it was not too bad. Hope so. Ask me. It's not the end of the problem though. But we did find y prime.
But this is not the problem on, or this is not on next week, right?
No, this is not. Next week. So you see, it's always right-hand side over the brackets. Was there still part B? Yeah?
I was going to ask why 4.
Yeah, part B. Right? Yeah. Let me check. The part B says, well, we actually wanted to plug in some number, 4 and negative 13. That's what you're asking?
Just plug in.
So I wanted to ask you, did you notice something unusual? We used to find derivatives so many ways, like so many times. This is the first time we see such an unusual result. What is unusual about it? Does anyone notice?
There's 2 variables.
There are 2 variables in the answer. We never had this before. This is slowly preparing you for the multivariable calculus with many variables. The answer has input and output. How interesting is this? So the answer of implicit differentiation includes both input and output. Why? Because we never found y. We never had y equals blah, blah, blah. Since we never solved for y was dragged into this whole situation of differentiation and then left out in the answer. So, part B asks us to find, what were the numbers? Y of 4 equals minus 13. Y of 4 equals minus 13. Let me check again. Yeah. And this is why they gave us 2 numbers here. This is my x, and this is my y, and both are needed to plug in, part 2. Y prime will be minus 6. X is 4 minus 2 minus y is minus 13. This is my y and this is my x. And both are needed for implicit differentiation result because we have both x and y in the result. 4 goes here plus 40. So if we ask to find the slope, that's the derivative at the point, now we need to have both input and output. Simplify everything and you will get minus 13 over 44. Good job. Thank you. So it's pretty cool that we have both x and y. Well, I don't know, cool or not, but it is unusual. We never had before the answer that involves 2 variables at the same time. Pretty cool idea. Doable or not? What do you think? Kind of annoying, but steps are pretty straightforward. The most important step is number 1. You need to differentiate everything. And then you start relocating the important things to the left, not the important things to the right. That's why I have this joke here. We just take all the y primes and push them somewhere else. So choose the side. I choose left-hand side. Just push them to the left. That's exactly the idea of implicit differentiation, okay?
You know what? Let's just have the nominator take the whole problem and push it somewhere.
Example number 2. Example number 2. 9 plus 6x equals sine of x times y squared. Pom pom pom. Chain rule. How do I know chain rule? Because there's something inside of the sign. And that something is complicated. What do you think? Yes?
What would the question in the exam ask of us to do these steps?
It will just, so let's see, the question was just find y prime. That's the thing. We just keep finding derivatives for like 3 weeks already or a month. And now the question is the same, but the original information is different. It's more complicated. So still the question says, use implicit differentiation, or it even doesn't say that. To find y prime, you look at this and you're like, oh, this is a mess. Exactly. Because it's a mess, you have to use implicit differentiation. Mm-hmm. And sometimes we ask you to plug the numbers just because it's easy to grade if we see the numbers. If you give me minus 13 over 44, probably your implicit differentiation is correct. If you gave me a different number, I have to go and see what the mistake is about. So the question is very simple. Find y prime. Look at that, how simple the question is. The thing is, you cannot solve for y here. Even if you use arcsine, then there's a square root. Sometimes the solution will not have unique answer. So implicit differentiation is very popular in applied mathematics. And applied mathematics means physics, biology, medicine, neuroscience, space science, and computer science, and so on. Step 1. Step 1 is differentiate everything you see. The huge bomb, just differentiate everything. 9 gives you 0, 6x gives you 6. Sine, derivative of sine, and I don't see what's inside, but I see it's chain rule, right? Derivative of, let me show you that this is function inside, chain rule. Derivative of sine is plus or minus cosine? Plus cosine. Then chain rule steps in and says, oh, there's a function inside. So this is my chain rule. I think there's a function inside. Please differentiate the function inside. Inside you see x times y squared, which is a product again. So it's a product rule. See? And now you carefully repeat the product rule idea. So, derivative of u is 1. Copy y squared plus copy x. What is derivative of y squared? That's the hard question. It's definitely 2y, but then what's the difference between y and x? Times y prime. So sometimes we teach you, if you have a panic attack during the exam, at least memorize. Every time you differentiate something with y prime pops out. From the chain rule, it's like inside over there, it just pops out. While when you do the same with x, it doesn't. So y squared, 2 goes down, that gives you 2y times derivative of the function inside. Function inside is y, so times y prime. Make sense?
Oh, because the one.
The difference is derivative of x is 1, while derivative of y is y prime. That's the difference.
Because I was trying to understand why 2 by y prime squared equals.
That is because of the chain rule. Y squared. 2 goes down, y, change the exponent to 1, times the chain rule. Chain rule says y depends on x. So the derivative of the function inside is going to be derivative of y, which we don't know what it is. That's why we're doing implicit differentiation in the first place.
So it's 2y times y.
2y times y prime. Make sense? Good questions. Yeah.
Does the extra like y prime like come out when it's during the chain rule?
Every time you differentiate something with y, it will pop out.
Okay.
Because y is a complicated situation, while x is not. That's fine. Yeah, I got the question. This was a good question. So this was all outside of this cosine thing. See, it's all multiplied by the cosine.
Professor,
Yes?
if it was y to the power of 5, it would be 5 y to the power of 4 times y prime.
Yeah.
Oh,
Y to the power 5 will be 5y4. So you start the way you know how to start. Then times y prime. Cosine of y will give you minus sine y times y prime. And so on. Look at it. Step 2. So we finished step 1 and we hope we did not make mistakes. Looks good to me. But now step 2 says move things with y prime to the left hand side. But I cannot because they are all factored out. So sometimes you have to do distribution. Because I definitely can see that there is only one y prime over here and it's multiplied by cosine. So we have to do extra distribution. 6 equals cosine x times y squared inside of the cosine times y squared distributing plus cosine of x times y squared times this part we actually need 2y times y prime. This is the part we are looking for. Yeah? Did I make a mistake?
I don't understand.
Oh, that's, good job for saying that. So I took this and I distributed it.
oh.
Yeah, good job for saying that, because, I don't know, you have to speak up.
Distribute that onto the active level.
Right? Cosine times y squared and cosine times... Oh, I lost x. Did you notice? This x got lost. So it is times x. I lost the x. Like so. Don't lose this x. So carefully distribute. Distribute will multiply everything out. You don't need parentheses when you move things around, that's why. Ask me, what do you think? Agree, disagree, comments, critics, suggestions. Y squared, yeah. So distributing.
Now, why would it not be like the cosine times 1 times the cosine times y squared?
The cosine times 1. Oh, 1, I just, 1 is multiplied by y squared, so it's over here. But I just did not write it down because it's 1. Make sense? Because it's sum, because of the summation. I see what you guys are confused with. Let me write down. I would do like this. Cosine of, z multiplied by 5 plus 10. You distributing cosine z by 5 plus cosine z times 10. Make sense? That's what I did. It's just very random example. So there were 2 things. Right? Cosine is multiplied by the first part plus cosine is multiplied by the second part. Make sense? Yeah. I see. You guys are asking stuff about inside of the cosine, right? There were several questions, and now I can hear what you're talking about. Do not touch this part. Why we cannot touch x times y squared? Because it's the angle of cosine. You cannot take it out or distribute it. Make sense? It's the angle. Sometimes we call it theta or pi. Keep it there. So you cannot distribute pieces inside. Make sense? It's glued to cosine. And actually has different meaning. If this y can be like centimeters, this is angle in degrees or radians.
Still never quite understand the trig rules. It never makes sense.
More questions? Those are good questions. You guys definitely, good job. Did it make sense? Yeah, distribution. So last time I will say it again. Last time I took this cosine, multiplied by this and this. So I have a huge sum over cosine multiplied by this and the cosine multiplied by that. Do not touch the angle of the cosine. Yes? Now, next step is to identify pieces with y prime. Are you guys done? Pieces with y prime, we only have one, which is this huge cosine part with y prime at the end. That's why we did all of this work. Let's move it to the left-hand side, or you can keep it at the right-hand side. Both are fine. Which one do you prefer? I would move it.
Moving it to make it negative.
Yeah, I know. It's a little bit down, but it's not make it wrong, so it's fine. Step 2. Minus cosine of x times y squared times x times 2y, y prime equals. Tell me, do you get what I just did? I took this whole piece that involves product with y prime and moving it to the left-hand side. To the left-hand side. So I changed the sign and just relocate it to the left-hand side. Because of this factor, y prime is important. Everything else is not important. So I will put minus 6. It was on the left. Now it's going to be on the right. And minus cosine x times y squared times y squared. Again, very good question. Why we cannot multiply this? One is the angle inside of the cosine. Another one is y squared standing
Why
outside.
is it negative?
Because, oh, it's positive. Yeah, good job. Good catch. But negative 6 though. Why did we do that? Because we want to have factored out y prime,
Is that last part y prime? Okay.
right?
Can you scroll over a little? I can't see what's at the end of the second equation. Or times y squared.
Times y squared. Yes, y squared.
How do you get y prime out of cosine?
There's no y prime inside of the cosine though. See? We just need this guy. So what is inside of the brackets? Minus cosine x times y squared times x times 2y. That is not even factoring, to be honest. It's already factored out. Yeah, we just take the part of it. You're right. Equals right-hand side. Some students are lazy to write it down. I can approve that. Yeah. And the last step will be y prime is right-hand side, which now you have to write down. Right-hand side is minus 6 plus cosine x times y squared times y squared all over the whatever is in the brackets. The brackets is, I know, look at Jesus. Minus cosine x times y squared times x times 2y. And this is the answer. It looks messy because it has to be. If the original function was messy, the derivative of the messy function will be also messy or even messier. And that's how you know you did good. Good job. It's very rare the derivative will look better. And again, the answer both have x and y's. Yes?
So the y prime we took out. Well, like I understood the last problem because it was like in both of the like it was in both sections, I guess. But this you just took it out, and I don't understand why it correlates to like really.
So it was like over here, right? It was multiplied by this minus cosine and an x and 2y. So it's not like I took it out, I just identify it. So you don't have to call factoring in this case, to be honest. I just put it in the front. Right? I did not really factor. It was already factored because it's like one piece. If there are 2 or 3 or 4 pieces with y prime, you factor out from all of them. But if it's only one piece, it's just a technical thing to say. I'm factoring whatever is already factored. Make sense? Good question, yeah.
But not enough to do it again, to do it by myself. If that makes any sense.
So this was, let's see.
I could probably tell you if you were doing it wrong, but
Oh, I had it here. So this was the original function. I have it copied. This was the original function, and we found y prime out of here. So this is my y prime.
There's no like second.
Nah, no plugging in. We could, but no, I don't have to. Unless there is, yeah.
Because like the first one had an and.
Yeah, this one doesn't have. That was the additional part B. So it's not always there. Yeah.
Why don't you put whatever you multiply the signs before the cosine?
Yeah, you don't have to, honestly. You know, there are many ways to reorganize it. To stick to my steps, I did it. Yeah. Let's see if I have more good examples or not. Oh, one more. Let's start one more, and then this is what implicit differentiation is about. So we will finish more on Friday. Third example. 5x minus y to the 4 plus 4y cubed equals 1300. This is a very typical exam example, to be honest. This is what we put in the exam, so it's nice to work out on this. Put a star. We like putting examples like this on the test. Differentiating using chain rule. Chain rule says, so solution. I'm differentiating both sides. 4 goes down, copy, change the exponent, times the derivative of the function inside. Keep repeating this, that helps a lot. So, 4 goes down, copy 5x minus y. Chain rule starts. Now, chain rule says, look inside, there's a function inside, and I see it. It's 5x minus y. What is derivative of 5x? But what is derivative of minus y? You see, amazing. So I already see you can do this example on a test. Just make sure you first finish power rule, then times, then derivative of the function inside. What is derivative of 4y cubed?
Y squared, y prime.
And don't forget, every time you have to deal with derivative that involves y, y prime pops out.
And all that equals 0, right?
So, is it correct? That surprisingly is one of the most common mistakes in the test. People get excited that they finished differentiating and they forgot the right-hand side. 0. So make sure you remember this. On the test, I can see the anxiety hits in, and half of the class leaves the number, and it messes up the answer really bad. So I keep mentioning this all the time. Yes? Yeah. So let's see. 4x cubed prime is 12x squared. Done. Because it's a simple input, no chain rule. But 4.
Put an exclamation point. It's factorial now.
No, when I circle it, it's not.
Good point.
Yeah. 4y cubed prime is 12y squared. And because y depends on x, you remember that y is a complicated case, you need to multiply by dy over dx. Or I like writing y prime. Make sense? It's simple. It's a simple input versus simple input versus differentiating the output, which is the dependent function. So every time you have to deal with y, when you differentiate it, y prime pops out as a chain rule result. Result of the chain rule. Yeah. Make sense? I hope so. It slowly gets in. Do we have to distribute here or not?
I believe so.
We do. People who said no, you're just optimistic. Because you see this guy, I need it together with this. So one more step is distribution. 4 times 5x minus y cubed is multiplied by 5. That's distribution step 1. So I'm putting here and then here. Right? Minus 5x minus y cubed times y prime. Make sense? Distribution. Let me write down once. Distribute plus 12y squared times y prime equals to 0. You look at it, you stare a little bit, and you find the pieces that involve y prime. This piece and this piece. Luckily, they are already on the left-hand side, so I don't have to move them around. I just need to keep them. So I will keep, yes?
It's with 0 on the other side of me.
Yeah. I will keep the parts that involve y prime. and then move everything else, which is basically garbage. We don't really need it that much until the very end. Minus 4, because it used to be plus 4, 5x to the minus y cubed times 5. This is what I did. I moved this part to the right-hand side, so it's over here with a negative sign. So I'm just moving things around. Important things involve y prime. Not important things, move it to the right-hand side.
The 5 isn't done with 3.
Yeah?
Sorry.
Distribution. So the distribution is like here is the part, and I'm multiplying it by 5 minus, and I'm multiplying it by y prime. So I'm repeating this part twice. Multiplying by 5 minus multiplying it by y prime. Distribute means you multiply out, piece by piece, saving the minus between.
But you're not really like putting the number in. You're saying you're not putting like 4y prime times 5x.
No. Good question. You don't do this one in because of this cube. I know, I can see why you're confused. The cube seals the parentheses. You cannot undo the cube. That's why.
So y prime is like in all of those little numbers, or just putting it outside.
Yeah.
So we can technically multiply by 5.
Yeah. And let's make it easier, to be honest. You don't have to do too many steps.
Okay, but it is distributed. That's
Yeah,
what
exactly.
I understand.
Yeah, good job. Very good. We are almost done. One step left. I will skip one step and you tell me if you get it. I'll write down y prime equals. Y prime equals right-hand side, which is already in front of you. Minus 4, 5x minus y cubed times 5. That's my right-hand side. Over the brackets, and that's the step I skipped. What will be the brackets if I, in my mind, which we call mental math, right? Mentally, factor out y prime. I even circle it for you. So I'm factoring out these pieces. Whatever is left will be going into the denominator, which is minus 4 times 5x minus y cubed plus 12y squared. Let me underline this piece and this piece goes into the denominator, and this is the answer. If I don't tell you to simplify, this is the answer on the exam, and you saved lots of time right now.
Because
Yes?
I feel like there's errors here, and I'm trying to.
Just a second, let me do the questions, yeah?
I don't know what
Let me do this. See you Friday. Yes.